Okay, so this is just an introduction on modeling, walking through the entire plane extension workflow in my main video, which I will link below. This is just showing you the entire workflow in one go. Whenever you do this workflow, you have to start with a reference image. So this is the single reference image that I had for that sword. This is the only art of it that exists. So you're going to take that image, you're going to make sure it's just the part you're going to model. And then this is me going to bring it into Inkscape, where I can set up the dimensions. This wants to be 4 feet long, so we're taking this down to millimeters instead of meters, so everything is sort of 1/10 of its size. And then you need 2 views in order to use the plane extension method. You need a side view and a front view orthogonally. There's only the side view exists for this, so I'm making sort of a mock-up of the front view. I'm just using the ability to make rectangles, which I'm going to size to the actual art. I'm going to set it at the thickness that I want. I know that I want this to be 2 inches thick, so I'm setting that here in Inkscape. The great thing about both Blender and Inkscape is that you can actually put in the actual dimensions, and they'll be there. You can so you can reference against one another. I'm marking where the center of it is. If I was looking straight on, like where the edge of the blade is, I'm doing that for both the blade and the grip. And then the grip, if you notice, actually has this sort of inset in it. So I'm marking both the center of the blade and then the sort of the inner and the outer dimensions if you were staring at it face on. So this is going to be creating the side view and the front view. And what I'm going to do is export these as images. And once these are exported, I'm going to go into Blender and import them as reference images. Again, the details for that workflow are all in the plane extension video. This is just showing you that whole workflow in one go. So taking about 3 hours of work down to 24 minutes here. So you import them, you get them aligned with each other orthogonally. They'll come in at weird angles, so you want to get those angles lined up. So now you have a side view and you have a front view, and you're going to see me switching back and forth with the 1 and the 3 keys a lot in this, because that is really the heart of the plane extension workflow. And here I'm inserting a mirror right along the edge of the blade, and then my first plane that everything else is going to be extended from. I'm getting it sort of right along the edge there. I'll make it smaller, and then it's going to be mirrored. So this is going to be sort of that basically 1 inch right along the blade, and then it's going to get mirrored, so it's 1 inch on the other side of the blade as well. I'm just going to be flipping back and forth. This will happen a lot. So yeah, and now I'm making it a little smaller, matches the blade width. Then we apply the mirror transformation. Now you've got one on each side, and as I extend the one on the right, the same thing will happen on the left. And then we're just going to start, once we've made sure they're lined up along the center there, we drag the outside edge to match the center, and then we just start dragging up, and we choose an edge, and we hit E for extend, and then we drag them up, and that can get twisted around. We just keep dragging them up, and as we go, we move the vertices to keep it in line with the reference image. You can just extend them all up there. And again, at the beginning, because we started on the front facing and we moved the outside out and we left the inner side touching there at the center, all of these blade edges are going to be at the right angle because they were referenced there against the front side that we made. So we've now sort of made all of our sort of facets of the blade going up the blade. And again, they're very rough right now. You can see as we come out of there how it sort of extends off the blade. And again, whenever the angle changes, going back to the sort of the blade view and making sure that everything is lined up both on that side as well as this side. And this continuing to extend plane by plane. And again, it can be very rough. Everything will get made more detailed later. So right now we're just sort of baking a shell, if you want to think of it that way, that goes along the outside blade of this, that sort of bottom part touches the blade and the top part touches where the angle changes. And you can see we're just making sure that from the front view, we have the exterior edge of the blade at the far end and the interior blade at the center. And now we're just going to extend those facets upward along the face of the blade. And then to sort of make them fit together, you select the two vertices of the two faces there and choose from the contextual menu, merge at center, and that's going to take these individual facets and merge them all together. So you can just extend the plane by clicking the edge and hitting E, and then you can go back through and just select the vertices and merge them, and those divisions between the planes will get sort of merged together. And again, because we're extending them off of the plane that's already at the right thickness, we don't have to go back and forth to the blade view every time because we're just extending them. You want to make sure that you're only moving them in that plane. Right now we want to make sure that you are, when you drag them out, you are constrained to that actual plane, left and right and up and down, that you don't actually move accidentally along the Z-axis. That should only be moved when you're on the view that faces the blade. So as you can see, we've extended them all out. Now up here, there's this sort of weird curve, so we have to do a little bit more tricky geometry. Whenever you need a point of turning, if you don't have one, you can always right-click an edge, choose subdivide. That will put an extra vertice in it so that you have a place where you can change the angle in a given edge, as you see me doing there. Making it opaque, get a better sense. And you can see we now sort of have this outside shell. And here at the top, the angle's a little bit different. So you see me going back and forth from the edge view to the side view, getting these things all properly lined up with each other. Again, this is just going through 7 times the regular speed. So for better detail, you can look at the instructional video, but this gives you a sense of how it all works together. Now you see me doing exactly the same thing on this edge. I extend each face along the edge, and then I go back to the blade view and then I pull that edge back to the center line so that it closes up. So once again, we extend the faces. We choose to merge vertices to get all the faces to connect, and once they're all merged, you're going to see me select all those outside edges. I think I do it all at once here. No, I'm going to do it one at a time, and for each one of those, each vertice, I go back to the face edge, pull it into center, and that pulls those edges to center and closes it up along the back. So going back and forth and back and forth. At 7 times speed, I'm sure it's a little bit confusing, but hopefully you get a sense of how this process moves, moving each vertices first along the X and the Y, and then the Y and the Z to close in the shape. And that has basically sketched out much of the shape, but we still need to close up the back along the back there, along the top part. So once again, you'll see me extend the planes and then merge the vertices. There's that weird little connecty bit there that we'll need to work about. And of course, everything is being mirrored on the other side, so we only have to do this on one side because we have the mirror modifier that will apply later on. And again, you see me going back and forth, moving the vertices into lines so it closes up those edges. And here, moving them around, merging the vertices to close this up. You'll see me go to the side to navigate this sort of fiddly bit here. And that was the blade. I do the same thing up here at the top. Again, just taking a plane, mirroring it, extending it. And I've done this for those faces there. Now, as I pointed out, this one has some extra depth, those blue lines in the facing piece. So in this case, you see me extending them up. This is going to be the rays of the ridge. So each of these pieces, once we merge the vertices, we're going to go to the side instead of sort of moving them from the center of the blade view. Yeah, I select all of them, and now I sort of pull them out. And so you notice the faces that were there went up to the blue line, and then this face goes the length of the blue line to the outside, and that's going to give us that ridge. So again, just going back and forth between the center and the front. You'll notice that my reference images I have at about 70% opacity, and that I go back and forth between full opacity and transparent when it comes to the planes that I'm drawing. And so this is that same plane extension workflow that you saw before, taking the planes, extending them. You notice they don't have to even fit properly at all, because when we merge vertices and we select the relevant vertices, they're going to close in. In some cases, we may actually need to make an additional face like that. In those cases, you just choose the vertices, right-click, and choose face from vertices, and it will connect all of those with its own new face. And this is just me moving them around, making some smaller adjustments to get the curve. And then, just as we did on the other, you'll see that we're going to close in the back side as well in the same way. Oh, here, this is me realizing that the blade actually has a small change in the angle of it. It's not a straight sort of plane that goes down. It actually shifts halfway through. So this is me using the loop cut tool to try to draw sort of an edge along the blade where I can then select all that and move it out. So we're changing the angle of the blade a little bit there. That's just what was going on at that particular time. I think what happened is it didn't quite work, so this is me doing it again, making the loop cut, then moving all those vertices out to change the angle of the blade, and realizing that the loop cut stopped down there at the change, so I had to do it at the bottom as well. And just moving it out a little bit. As you can see, there's a lot of fiddly back and forth with this. And then, yes, this is me extending the planes to close in the grip. So just generally what you're seeing is we start with a plane and we sort of build a shell for one face, and then it wraps onto the next face and so on, until finally we enclose an entire object. Again, moving those vertices so that they touch along the face view. And still this little bit have to close in at the top here. And this is me selecting vertices, realizing I need to actually make a face. You always want there to be 4 vertices. 3 can be acceptable, 4 is better, 5 is not good, or anything more than that. So in this case, you see me selecting 4 vertices to make a face out of the vertices. Select me those 4, that creates the face, select those 4, that creates the face, and that closes in that. And now we have the rough shape of both the blade and the pommel there. There are these little rivets, and so what we're going to do is we're going to take our cylinder, we're going to move it down to size, match it all up. We are going to mirror this cylinder because there are rivets on both sides, and that way they stay exactly aligned with one another. I think actually this is first testing, okay, where is this cylinder is going to become the grip. We're not actually going to print out the grip will be PVC pipe, but it will be useful to have an object here to represent it and to boolean it out when we get to that phase. So we're going to start with the pipe that becomes the grip, and then the cylinder that becomes the rivets, that's this one here. And so once again, we get it down to the right size, flip it around, and then we just match it up with its position. We're going to mirror it because it exists on both sides. There's the mirror modifier there. So now we have one on each side. And then we'll just copy it and move it up, and that mirror moves along with it because we're copying and pasting. So now we have our rivets there, we have some rivets down below. Notice the list of objects getting very long on the right there. So in a moment we're going to boolean together all of these into one object, one sort of rivets object. They don't have to be touching to get booleaned together. So you see us booleaning all these rivets together, so they are one rivet object. But we haven't actually connected it to the blade. It's just its own sort of set of rivets there. So yeah, that's the rivet objects, and so making sure they're aligned along with the blade view there. There's a lot of going back and forth. And now we apply the modifier for subdivision surface, which you see makes it very, very smooth, and we don't want it to be completely smooth. So we're now going back in and setting the edges we want to be hard. So again, we choose the object we want, we choose modifier, subdivision surface, Katumli-Clark, and that makes it super smooth. But we can still see, from object view, the actual edges of the shapes we made before. So what I'm doing now is I'm selecting the ones we want to be hard edges, and then choosing mean crease 1. We'll go from 0, that's fully smoothed, to 1, that's completely hard. And what will happen is that those edges then will be hard edges, and the others will remain smoothed edges. So this is the trick. You see me having to go back through and figure out, okay, why is everything smooth? I don't want to be smoothed. Oh, there's a connecting edge there. And then I do the same thing with the pommel. What I realize here is that this is a much more geometric shape than the sword, and so I end up applying mean crease to pretty much all of the edges here. It's only the interior edges that along that curve that I keep smoothed out with the subdivision surface modifier. And so you see I've now applied that, and you see me now here booleaning together all of those rivets, making sure that they're actually, instead of their own object, we boolean them onto the main blade, and then we can delete the old object. And so we've now smoothed the blade. You can see how much better those curves look while still having some solid edges to them. This is me going back and forth between inches and meters. I realize things aren't quite the right size, so I make myself a reference object that is 4 feet long in meters, and I scale up my object to match it. And this is the great thing about sort of making yourself a ruler to make sure that everything matches properly. I go back, I know I'm making this in terms of feet and inches, but within Blender everything is in millimeters or meters, so you see me doing a lot of conversion there. This cylinder I'm moving, the grip, will be a piece of PVC, and so I'm making this, I believe the actual piece of PVC is 1.5 inches, so I'm making this just a bit bigger so I can boolean it out of the existing shapes, and that will leave us a hole that the PVC can go into. And a great way to do that is to have a piece of 1mm EVA foam that you use to make a gasket to sort of line the hole that you boolean out, and then the PVC can slide in and the EVA will sort of grip it, and you can have it hold together without glue, and that way you can take it apart, and batteries for LEDs can live inside that grip, because a 1.5 inch PVC is exactly the size for a battery clip, a AA battery clip. Now my printer prints 9-inch cubes, so you see me, I have 2 9-inch cubes here that I'm using to divide this into pieces to print. Your slicer software can probably do this itself, but because I have some fiddly interior geometry, I decided I would do my slicing into printable pieces here in Blender. So what you saw there was a 9-inch cube, and I'm just booleaning out the pieces, making those cuts. Again, I talked about that in my main videos. So we have pieces that are all under that 9-inch cube that we need. And then in a moment, what you're going to see is, I think I boolean out the grip first, and then I'm going to be going through face by face and adding the tongue and groove. It will help these fit together properly. Just double checking the width of this pipe. You see me making some very small fiddly adjustments, because I don't want the pipe sort of cutting through the edge there. I want there to be that little bit of a margin. Making sure, using the under transform, the align objects to make sure things are perfectly aligned with one another. And then, yeah, I think this is me booleaning out the pipe, and you can see the hole there where the PVC will eventually go. And now I'm going to go through each of these breaks and add a cube. I make one part in, so it's hidden, it's still there, but it's hidden. Add a little cube to the face of one, where I boolean it together. Just me getting things sort of centered and sized properly. And then it goes quickly, but I'm going to then boolean that piece out of the connecting piece. That one gets booleaned out, and then, so that makes a hole, and I make that touching face smaller, so when I print those out, those two will socket together really nicely. sorry, there's a clip of me checking classical music as I'm rendering here. Apologies about that. And then you're going to see me do the same thing here, making ourselves a tongue with a cube that gets set into one face, and then I will boolean it out of the touching object. I'm just taking that boolean out. You can sort of see it showed there for a moment, the groove that it makes in the other object that you can then use to put these together. Now I'm sort of putting the tongue right in the middle of the face because there's going to be two additional channels that run through the blade, one for the LEDs at the edge and one for some dowel, basically to give it additional strength that runs through the back. So the tongue and groove is right there in the middle of the piece. So this is adding the channel at the front. I know I wanted basically a 3/4 inch channel, so we're making a 3/4 inch cylinder that's just going to run around the edge. The LEDs are going to fit into this, and this doesn't have to be particularly pretty, just needs to be there for the LEDs to exist in. We're printing this out in translucent filament, and so we're just booleaning out that cylinder from the pieces. You can see the hole there, and of course these pieces are going to be perfectly aligned with one another because we're not moving any of the sword pieces. We're just hiding them and unhiding them as we need to move things. Now I've made the whole cylinder smaller, and so I've cut that. You can see through the curve. I'm going to do the same thing here toward this S curve, just keeping the same width, diameter of the cylinder, and just changing its length and its angle to run along the blade so it intersects with our existing pieces without cutting through the surface. And then we just boolean that out and running it so it runs into the hole we've already cut for the grip. And that way we can run the batteries, cable from the batteries and the grip to the LED strip there along the edge. And then you're going to see me do the same thing with a smaller, narrower piece that we're going to use as a 1/4 inch dowel. So just making this a 1/4 inch, actually a little bit less than a 1/4 inch, actually a little bit more than a 1/4 inch, sorry about that, because there will be some tolerance. And then that's going to run along the back there. We'll boolean that out, and then we'll have an additional dowel. It will just give it some additional strength. You can get those at craft stores, and you can sort of see how those holes fit together. And then these pieces are ready to print. The 3 pieces of the blade and the 2 pieces of the handle, you see them printed out there in translucent filament. Of course, these will get painted and finished in various different ways, but that was the whole process to start with a single reference image and turn it into a 3-dimensional object. There you can see it sort of from the side. When you print in translucent filament like this, you can add LEDs to it. They will shine through it. You want to, of course, sand the edges to diffuse the light. I have another video on that which I'll link below, but that's the whole process. It took about 3 hours from first getting the image to creating the shapes, boolean out the various pieces, and that's the whole thing. Please drop me questions if you have any of them.